Let's talk about piecewise functions. A piecewise function is a function that's broken up into parts. It's like a combination of graphs. We take a function and we cut it off somewhere and put it with another one, and it's based on this word if. So this is the function f of x equals 2x if x is less than or equal to 1, and 5 if x is greater than 3. So two different things are happening depending on what your input is, depending on what you plug in for x. So for this case here, if we're going to plug in a number less than 1, like if we plug in a 0, well, I'm doing f of 0. That's going to go into this one here. Plug in a 0 here, I get out 0. And if I do f of negative 2, that's also a number less than 1. I get out a negative 4. But if I were to do like f of 8, well, if the x value is greater than 3, the y value, f of x, is always just going to be 5. So f of 8 is 5, f of 10 is 5, and f of 600 is 5. That's what these two graphs are showing here. If ever the x value is greater than 3, the y value is 5. But if the x value is less than or equal to 1, if the x value is less than or equal to 1, it behaves like the line y equals 2x, because here the slope is up to right 1, and the y-intercept is at 0. These are two different lines that are composing one function depending on what's happening to the input. And I'm going to show you two different ways to graph these. One of them is by plugging in points, one of them is by erasing lines. You graph the whole line, then erase part of it. You're going to probably find the best way to do this is a combination of these two, but I'll show them both separately, and if you get a feel for one, try and stick with that one. So I'm going to graph this function, f of x equals all of this stuff, depending on if x is less than negative 1 or greater than or equal to negative 1. If x, and this is called plugging in points, so what I'm going to do is make a table of values where x is less than negative 1. And remember, y just means f of x. And I'm actually going to include negative 1. And I know that negative 1 isn't less than negative 1, but I want to know where this line is going to stop, or start, depending on how you think about it. But like where the open circle is going to be. This is going to have an open circle because it's not equal to. This will have a closed circle because it is equal to. But let's plug in numbers. If I do f of negative 1, if I plug negative 1 into this function, I get out 2. If I do f of negative 2, I get out 1. F of negative 3 is 0. F of 4 is negative 1. So I have negative 1, 2. That's an open circle. Negative 1, 1. Sorry, negative 2, 1. Negative 3, 0. Negative 4, negative 1. I have this line. Make sure this line's set up the way that I want it to be set up. Yeah, that'll work. This is the line y equals x plus 3. It stops at negative 1. So it's really like a ray, because this is where it stops or starts, depending how you think about it. But this is the line y equals x plus 3 if x is less than negative 1. Now I'll graph where x is greater than or equal to negative 1. Again, I'm going to use negative 1. And I plug in numbers that are greater than or equal to negative 1. And you might be confused saying, well, how come you're using negative 1 twice? I'm not actually using this negative 1 because it's an open circle. I'm using like negative 1.0001, like everything really, really close to negative 1 without actually including negative 1. That's what that open circle means. This one I'm actually going to plug in negative 1 and use a closed circle because I'm including that point. I plug in negative 1 to this function. Negative 2 plus 3 is 1. I plug in 0 to get 3. I plug in 1 to get 5 and 2 to get 7. Negative 1, 1. 0, 3. 1, 5, 2, 7. That is my piecewise function. It's got two pieces of it. One of them is y equals x plus 3 if x is less than negative 1. The other is y equals 2x plus 3 if x is greater than or equal to negative 1. I just graphed it by plugging in points and checking out where the graphs are going with those points. The other option, and this is the one that I kind of prefer, is to graph the entire lines completely right off the bat. So first I'm going to graph f of x equals x plus 3. And I'm not going to worry about, I'm going to do this in yellow, I'm not going to worry about where it starts or where it ends, I'm just going to graph the whole entire line. This is the whole line, y equals x plus 3. Now I only want to keep the stuff where x is less than negative 1. That's what this right here is telling me. I only want to keep the stuff where x is less than negative 1. Well, here's where x is negative 1, and here's everything less than it. I'm trying to keep everything that corresponds to that shaded part of the x-axis, by which I mean I'm going to keep everything here and everything to the left. Yeah, I can probably keep that. That's fine. So I am going to make this an open circle, because it's not equal to, it's an open circle, and all of this I erase. And for me, instead of erasing, I just kind of shrink it down. And then I'm going to change the endpoint, I think, like this. Yeah. That is the first piece of the line. Then I'll graph y equals 2x plus 3. 2x plus 3 goes like this. Yeah, slope of 2, y-intercept of 3. I'm going to keep everything that goes to the right of negative 1. To the right of negative 1, which is going to be all of this stuff. So I erase, or in my case, shrink this. That's the erasing line methods. Here's kind of an overall way to think about this. Here's a piecewise function with 3 pieces to it. A yellow piece, a pink piece, and a turquoisey piece. I graphed all 3 lines, a yellow line, a pink line, and a turquoisey line, but I only want to keep pieces of them. So I'm going to erase the pieces I don't want, and I'm left with those 3, the yellow, the pink, and the turquoise. And this piece corresponds to this piece, and the pink to the pink, and the turquoise to the turquoise. So this is saying y equals 4 if x is greater than or equal to 5. Well, that means when x is 5, the y value is 4, and if x is 6, the y value is 4. And this says y equals 2x plus 1 if we're between negative 3 and 2, not including the 2. So that's the word between there. Between x of negative 3 and x of 2, we have these values. 3 pieces from 3 individual lines. Now, before we get too far down talking about how to do this, I want to talk about like where and why it's useful. We actually use piecewise functions all the time without thinking about it. Here's a list of the taxes from 2017 that I pulled up off the internet. No, 2016, sorry, last year's taxes from the time that I wrote this. Depending on how much money you make, you get taxed at a different rate. If you make somewhere between $0 and $18,000, your taxable income, the amount of money you're taxed on, is just 10% of that. But if you make a little bit over $18,650, your rate jumps up quite substantially, and you have to pay this flat fee. And the more money you make, the more you get taxed. And these are tax brackets. Well, depending on how much money you make, you will pay a different amount. It's a piecewise function that looks like this. Yeah. Your tax rate is going to be 10%. 10% if you make less than this amount of money, or exactly that amount of money. It's going to be 15% plus this fee if you're somewhere in this range. And the more you make, the more you're taxed, but you wouldn't ever like plug x into all of these things. Like suppose I made $50,000 one year. Well, to do f of 50,000, I wouldn't plug 50,000 into every single one of these pieces. I would just plug it in to this one, because that's where 50,000 fits. And obviously there's a lot of debate and a lot of opinions about if this is a good system or a bad system. So for example, my wife and I, and yes, I use the word wife there, so I'm sorry, ladies, if you're falling in love with the man behind the microphone with the beautiful voice who probably looks like this, or maybe like this, nobody really knows. But yeah, taken, so get over it. Let's hide those distracting faces. My wife and I are, like every year, right on the edge of one of the 2 tax brackets. And I won't tell you which one, but it's definitely not this one. And every year we have to think, okay, if we make like a few $100 to $1,000 more dollars, we might jump from like 25% to 28% and have to pay $19,000 more dollars in taxes. Or maybe from 28 to 33%, 5% more, plus $23,000 more in taxes. So we have to kind of work hard to not work so hard to jump up a tax bracket, which is sort of interesting. Like in a capitalist economy, which the U.S. is supposed to be in and is primarily in, you want to encourage people to work as much as possible, and we are kind of being discouraged from working a little bit more to a lot more because we just have to pay much money to the government. And my wife, who's in the healthcare profession, is somebody you want working a lot. So it's interesting. So people will talk about, like, well, maybe we should do a flat tax where everyone gets taxed the same. And then a lot of people argue, well, that actually taxes the poor really heavily, because 10% of the poor's money is actually a much bigger chunk of what they can try and live on than 10% of the rich's money. And I feel like, why don't we just draw a curve where you can get taxed more the more you make, but you're still always incentivized to make more money. But now I'm getting too political. We're here for math class. Let's just move on. I'm going to graph this, and I'm going to find the domain and the range. And I will do this one by graphing lines, because I like graphing lines the best. This has 3 pieces to it. First, I'm going to graph y equals negative x minus 4, a slope of negative 1. And I'm not going to give it arrows yet, because we'll just see what happens. There's the whole entire line. I only want to keep the stuff where x is less than negative 2. Well, here's where x is negative 2, so I'm keeping this with an open circle, and I'm keeping everything to the left, because I'm keeping stuff like I would plug in negative 2, negative 3, negative 4, negative 5. That's all this stuff going this way, where x is less than negative 2. So I want to get rid of all of this, and put an arrow on the end of this, because I'm pointing to the left forever. There is my first piece. I don't know if you like having this line here or not. I think I'll keep it so you can see how I'm finding those values, but that actual little green line there isn't a part of my graph. I'll erase it at the end. Next is x. So I just did this one. Now I'll do this one. X, if x is going from negative 2 to 3. Well, the line y equals x just graphs like this. I am keeping everything from negative 2 to 3, so everything from here to here. This is kind of interesting. One circle filled in the other. That's sort of fun. That means that this stretch of the graph is continuous, because the graph usually goes like this. This is the whole line, y equals x. That's all this is saying. This is just saying y equals x. But I want to keep this and this. There's my second piece. Third piece, y equals negative 3 if x is greater than or equal to 5. Well, y equals negative 3. Is this. But this is only going to be happening if x is greater than or equal to 5. Well, that's everything from here forward. So I'm just keeping, at equals 2, yeah. So I'm keeping this with a closed dot with an arrow on the end. And I can get rid of this now, I think. There is my piecewise function. 3 pieces from 3 different lines. I was asked to give the domain and the range. The domain is actually really simple. It's this. They always just give you the domain. It's right there in the constraints of your piecewise function. However, I'm going to clean it up a little bit because of how these overlap. Since this circle kind of got filled in, I actually only have to worry about 2 pieces. My domain is going from negative infinity to 3, along with 5 to infinity. That's me doing an interval notation. You could also do it with set notation if you'd like. I'm just going to show interval here. Think about it. It's going from 3 backwards forever. There's always an x value associated with 3 and back, and always an x value associated with 5 and forwards. And that's where it's going to be kind of nice to plot these lines on the bottom like I do as I graph them for the domain and the range, right? Like the yellow part happened here, and the light blue part, turquoise part, happened here. And the green part happened here. And then you can just sort of look at your x-axis and realize everything's being graphed except for this little tiny window from 3 to 5. Range is less obvious. It's not just given to you. But remember, I talked about a scanner. Think about a vertical, or sorry, in this case, a horizontal line, just going and scanning up and seeing where you hit the graph. We hit the graph at -3, and then at -2, and up, 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 up forever, because right here is a arrow, up forever. So the range of this is going to be -3 in a set bracket, along with -2 to infinity. And I'm sorry, that should be a bracket and a parenthesis. Okay, we're going to do a couple more examples. Y equals 3x plus 1 if x is less than -2. Well, 3x plus 1 graphs like this. I only want to keep the parts where x is less than -2. That's all of this. So I'm keeping this and down. So I want to get rid of all of this. There's the first piece to my graph, and now I'm going to erase this. Next part is y equals 1/2 x. I'm just literally graphing the line y equals 1/2 x. I'll do it in yellow. If I'm going from -2 to 3. Oops, that's wrong, excuse me. One half x is going up 1, right 2, up 1, right 2, up 1, right 2. So it's going like this. I'm keeping this and this from -2 to 3. So I'm losing this and this. Finally, I have -x plus 2. Let's go pink. Pink is fun. Well, that line graphs like this. It has a negative slope, down 1, right 1. Please remember that I have no problem with you jumping around the videos, so if you feel like you're all set with how to graph these, go on to the next example, but I think doing examples is helpful. I want x to be greater than 3, so I am making an open circle there. And this is going like so, and then kaboom. The domain of this is actually everything except for the number 3. So I could actually just say x does not equal 3. That's actually the domain, everything except for 3. I should say x such that x is not equal to 3, really. This is set notation, x such that x is not equal to 3. Or we could say it's going from -infinity to 3, along with 3 to infinity. The range is going from, since this one here is pointing down forever, and these two overlap, they share, the range is actually going from -infinity to 1.5. .5 has an open circle, so that should be in a parenthesis. Now I'll graph it again, but this time I'll use the old plug-in points method. I'm going to make 3 tables. I'm going to make a table of values where x is less than -2, a table of values that goes from -2 to 3, and a table of values where x is greater than 3. And for each of these tables, I plot points, and I kind of look at the trends and see what this graph is doing. Well, if I plug in numbers less than -2, I actually still include -2. So I'll plug in -2, -3, -4, and those are all getting plugged into this first function up here. Plug in -2, you get -5. Plug in -3, you get -9, plus 1 is -8. Plug in -4, you should get -11, because the slope of this is 3. It's going up 3 every time x goes up 1, meaning it's going down 3. Y goes down 3 when x goes down 1. And I have those 3 points. -2, -5 is here. It's going to have an open circle, because I'm not actually able to include the -2. It's like I'm plugging in -2.1, or 2.01 even. And the graph moves like this, just like the green one is. Then I plug in numbers from -2 to 3. If I plug in -2, and now I'm plugging stuff into this function because everything's fitting in that domain. If I plug in -2, I get out -1. And then because I can just count the even ones really quickly, it's just a half of x. I just cut all these numbers in half. This is -1/2. This is +1/2. This is 1.5. Well, -2, -1 is here. It's a closed circle. It's going to go all along this to this open circle at 3, 1.5. Then I plug in numbers greater than 3. And I'm going to include the 3. And I get -3 plus 2 is -1. -4 plus 2 is -2. -5 plus 2 is -3. I get all these points here. So I'll get the same graph that way. Yeah, I think it just takes longer, but it's certainly very doable. Going the other direction now, we're going to write the equations of a graph from the graph. We're given a graph, write the equation. I've got 3 pieces. This line has a slope of 1.5. Sorry, 1 over 2, 0.5. And it's going to have a y-intercept right here at 5.5. This graph is happening if x is less than -1. The hardest part about these is drawing pretty wing brackets. Y equals 1 over 2x plus 5.5 if x is less than -1. Because that was this stuff here. That's all that stuff in there. Yeah. Next piece. Let's change its color. We'll do this piece here. This has a slope of down 3, right 1. I could just say -3x. And a y-intercept of 1. And this is happening if x is going from -1 to 1. Third one, back to my trusty pink, is just the line y equals -5. This is just right here, the line y equals -5. This is happening if x is greater than 2. Greater than or equal to. You want the domain? There's the domain. I can say it's going from -infinity to 1. As well as from 2 to infinity. Or I could list it out in set builder notation with all those things just copied down. The range, I have to actually look at the graph. This is starting at 5, and it's going down forever because of this. So nothing else here actually matters. The range is just going from -infinity to 5, and we're not actually hitting 5. Because of the open circle. One more graph example. This is the line. This is a slope of, there's a point, there's a point, there's a point. This is going up 3, right 2. Then I've got to find the y-intercept. Well, this one, sadly, if I keep going, from here to here, up 3, right 2, up 3, right 2, up 3, right 2, up 3, right 2, I can't actually see perfectly where the y-intercept is. It's not crossing at a clean point. I need to find the y-intercept. There's a couple ways you could do this. One is you could just set up y equals mx plus b. Pick a point xy, so here's the point -3, 2. Plug in 2 for y. Plug in your slope, which we know is 3 over 2. Plug in -3 for x, and solve this for b. That'll get you the y-intercept, no problem. But I think a slightly better option, the option that I prefer anyways, is to do this in point-slope form. Instead of writing the equation slope-intercept, write it in point-slope, which would be, if I use this point, x1, y1, it'd be y minus 2 equals 3 over 2 x plus 3. Now, to write this as a piecewise function, the y has to be by itself, so I add 2 to both sides. And I can say this is y equals 3 over 2, x plus 3, plus 2. There's the first piece of my piecewise function. This is happening if x is less than or equal to -3. point-slope form can be really, really handy here. Middle piece is y equals 2 if x is between -3 and 3. Third piece, y equals, this is just the line y equals x with a slope of, y-intercept of -1. I can just trace that backwards. So it's y equals x minus 1 if x is greater than 3. Or actually, it's just going from 3 to 7. And 3 is also an open circle. This domain is, again, everything except for 3. That's actually not quite true, because this stops. So it's this, on forever. So I'm going to say the domain is going from -infinity to 3, to very bad infinity, and then from 3 to 7. The range is going from 6 down. Or we'll say from down to 6. Thanks for bearing with me. Quick little example of a word problem we're done. I'm going to spend 2 minutes on this, so just hang tight. If your bag of Jolly Ranchers are on sale in a big bin in the middle of the grocery store, and the sign says half off on orders of 10 or more, each bag costs 80 cents. This is a piecewise function. Depending on how many bags you buy, the cost will be different. So if x equals number of bags, and f of x equals cost, then I could say f of x equals 0.80x if x is less than 10. And I won't bother saying that x can't go negative. We assume that. We're not going to say between 0 and 10, because we know we can't buy negative things anyways. Or it's 0.4x if x is greater than or equal to 10. You pay 80 cents per bag if you buy less than 10. You pay 40 cents per bag if you buy 10 or more. You do this instinctively without thinking about it this way all the time. Just try and start thinking about it this way. It'll help you. Okay, long one, but it's going to last us for 2 days. We made it. Wow, that was a long video. What's the deal with this guy just talking and talking and talking? This is the part of the video at the end where I tell you to do things, where you need to listen to me and share my video if you found it helpful. Like if you got a friend in class and you say, hey, I know this guy who makes videos, check him out. Then yeah, send out a link or subscribe so you can see more of my videos later and maybe see more of these cool animations. This is a point going around an ellipse at different speeds acting like an orbit. And that thing bouncing in the middle just makes pretty designs, although right now it's pretty lopsided. I can also just tell you to do other things like eat food and drink water and stop Snapchatting people so much, but you're not going to listen to me if I say things like that. Thanks for watching. See you next time.